This is AP Calculus Lesson 2-9. We're talking about the product rule. We are still on advanced derivatives. We're almost done with this unit. We're about to go to Yosemite also. The addition rule. So we've talked about this rule informally. This rule is essentially where you can distribute the derivative. So this derivative here distributes into both of these. So this really turns into this problem right here. This is really equal to, or it turns into, the derivative with respect to x, d dx, of x cubed plus the derivative with respect to x of 4x squared. And we've already seen this before. I just want to make sure that we really know that this is called the addition rule. They're not going to test you on this in the AP test or anything. But it's gone over now officially in the notes, and this thing now turns into, I need some people to help me, derivative of x cubed.
3x squared.
All right, thank you, Rochelle. 3x squared, and someone new, plus what?
8x.
8x. Perfect.
Why don't you write the d over d of x on the second part?
Say that again?
So you know how you separated them?
Yes.
And then the next one, why don't you put d over d of x?
And these ones?
Yeah.
Because I'm taking the derivative, so now that I've took the derivative, I don't need to write that. It's like applying this derivative to this function. And after I apply that, I'm left with 3x squared. Yeah. All right, so let's look at number 2. Yeah, that was a good question. Number 2, it's the same thing. I'm applying this derivative to both of these terms, to this term right here, and then to this term separated by wherever there's a plus sign. But it doesn't apply to this minus sign right here because that is technically the inner of the natural log function. There's no separate functions. For each function that you have, you apply the derivative. So I'm not going to write out d dx, or the derivative with respect to x of this thing. I'm just going to take it. So I need to find the derivative of this left-hand side. Can someone help me out with that? We're experts almost at taking the derivative now.
5 over, 2 times x minus 1.
That was Doubter, perfect. Someone do dinner.
2
times 2, perfect. So that was taking the derivative of everything on the left. We're done. Good job. Arrow, do you want to do the derivative of our e house on the right? So this is going to be plus.
3e to the x.
Perfect, that was Doubter. What's dinner? Anyone else?
What?
Perfect. So times 1, done. And then I can simplify this a little bit. That's why I gave myself another line. If you don't have room, hopefully you have room to the right. This now turns into simplified. I don't need to get it all into one fraction. I think just getting this left-hand side simplified is a little bit better. I'm going to simplify this into what? Someone do it for me, please.
5 over x minus 1. Oh, wait.
Close. Yeah, so be careful because that 2 doesn't cancel out with this term. You're thinking that you could just cross off that 2 and that 2, but this 1 doesn't have a 2 in it. So I think we're just going to leave the top 10. Yeah. So you want to read off for me, Rochelle?
10 over 2x minus 1.
2x minus 1, and then we still have that plus 3e to the x. Perfect. I guess I should be boxing all of our final answers here just to get in the habit. All right. Now finally, we have our next and final example. Taking the derivative. Go ahead and do this by yourselves. See if you get this. This is the derivative of the general function, and it's in my trig house and then general function. Trig house, general house. See how you do. And as you're working, I'm going to slowly catch up behind you. Should have an arrow here. I'm going to slowly catch up behind you. All right, answers now up on the board. See if you got the same thing that I did. Did you remember dinner? Are you going to starve? Give me a thumbs up, thumbs down. If you gave me a thumb down, that's okay because you're correcting your work now. I just want to see how we did. All right, what did we forget? Or what did we mess up on?
I couldn't remember how you would do the f of x.
Okay, yeah. Same thing, arrow. Yep, yeah. General house, you just do an f prime. Perfect. Any questions about these three examples? Oh.
Multiply the 3 and 2 to make 6 cosine of 3x.
Yeah, so yeah, you definitely want to, like, if you want to simplify this, I guess since we were simplifying all of our other answers, this would be 6 cosine of 3x. Whoa, my computer lagged there for a sec. 3x plus 4f prime of x. And for those people that are watching the video, if you hear that background noise, that's a 3D printer printing out hatchet planimeters because I'm on a deadline. All right, so now that we've done addition rule, let's do the product rule.
Can it work for subtraction?
Oh yeah, so the addition rule applies to subtraction as well. It's kind of assumed, but yes. So if there's a minus sign, leave it. I should have done example 3 with a minus sign, but oh well. Product rule. All right, so there's two things that I need you to remember. I'm going to have the first formula, which is the one that you'll find in the textbook, and then I'll do the formula that is easier to memorize, and that's probably the one that you should memorize. All right, so the one in the textbook, the derivative with respect to x, d dx, of two functions. I'm just going to say those two functions are f of x. Are you okay, Ben?
Yeah.
F of x times g of x. What happens when I multiply? We know what happens when you add and subtract. You just distribute, just as seen in the previous addition rule, previous slide. What happens when you multiply? You do this, and I could prove this to us if we wanted to. I just don't have enough time. If you want this proven to you, come see me at lunch. It is f of x. That is going to be multiplied by g prime of x. Then I'm going to add that to, and order of operations save me from having to do parentheses. If you think that you might mess up on the order of operations, you can give yourself brackets right here, but PEMDAS does tell us that we're supposed to multiply before adding, so you don't really need those parentheses. And that's going to be added to g of x times, what are you going to guess? F prime of x, yep, f prime of x. That's the one found in the textbook. Here's the one that I want you to memorize. The derivative with respect to x, d dx. I'm going to say function 1 times function 2. 1 and 2 represent functions. It's easier than writing f of x. You're just writing a number. That turns into the following. 1 times d2. So 1 d2. And I can give myself some space so it matches up here. Maybe I can even move this over in my notes so it matches right underneath. 1 d2 plus 2 d1. So every time I ask, what's the product rule? You're going to shout out 1 d2 plus 2 d1. So, what's the product rule?
1d2 plus 2d1.
One more time. What's the product rule?
1 times d2.
Yeah, you don't have to say times, just 1 d2. So, what's the product rule, everyone?
1 d2 plus
2d1.
There it is. Okay, we'll get better at it as we go along. Let's try this out. Try out our new weapons. That's why you want nuclear weapons, because you want to try them out immediately, right? Fun times. Sorry, Japan. Okay, sorry. Examples. Ejemplo número uno. Example number 1. Let's take the derivative with respect to x of x squared. I'll do this one with you guys. X squared times sine of 2x. And sometimes that time sign, like if I was the AP creators, I guess, I would definitely not give you that time sign. It tells you too much. I would have just written x squared sine 2x, and I would have assumed that you knew that this was one function and this was the other function. This was one house, this was the other house. I am in what house on the left? What house on the right? Trig house, yeah. And trig house has sine, cosine, and tangent, exactly. So this is going to be house number 1. let's label it. House number 1, house number 2. We know what function 1, function 2 are. All right, so you might need to write 1d2 plus 2d1. We have it right above, so I'm not going to rewrite it. So this is going to turn into 1. 1 is what? X squared times d2. What's d2?
Cosine 2x.
Cosine 2x. You guys agree? Ooh, shouldn't agree.
You have to do the inner too.
Yeah, it's doubter. Always remember your dinner. Never forget dinner. Times dinner, which is, shout it out, 2. Perfect. So that is all d2. This whole thing right here, this whole thing is d2. This whole thing right there is 1. All right. What do I write now? What is in between these two things? 1d2
2d1.
plus 2d1. Yeah, plus. And what's 2? Shout it out.
Sine 2x.
Sine of 2x. Perfect. I should do parentheses there. Sine of 2x. And that's going to be multiplied, divided, times, what's the operation that goes here? Times, yeah, d1, which is, say it again?
What about the
2x. Yeah. Oh, yeah. Did we forget something? So this whole thing right here, that should have been 2. Is that 2? It looks like it's 2. Okay. And then this whole thing should be d1. Is that d1? Okay, yeah, perfect. So I think we did get everything. It's always nice to double check.
Why don't you change it for the 2 times d1, the side, but you change it for d2?
Ah, good question. Someone else answered that. Why was d2 a cosine, but 2 was sine?
Because if you take the derivative of sine, it becomes cosine.
Yeah, so that's the rule. And if you need that again on the side, d dx, the derivative of sine, turns into cosine, and d dx, the derivative with respect to x of cosine, turns into negative sine. Yep. Good. I want to do 2 more examples. Example number 2. Let's take the derivative with respect to x. So this d dx of, I'm feeling a negative e to the power of x times, and again, if it was the AP test, I'm not going to be so nice, times natural log of x. I would have normally just said e to the x natural log of x, and I would have assumed that you could find which function was which.
But it's sometimes confusing to know if it's whether like
It totally is. It is confusing, like, do I have 3 functions here? Do I have 2 functions? Where are those 2 functions? It can be, and that will come to you with experience. Just doing this over and over again, getting them wrong, making mistakes, and finding where you made the mistakes. All right, I'm not going to label the 1 and 2. I'm going to assume that you know that negative e to the x is our 1, natural log is our 2. So, help me out. What do I write?
negative ex times 1 over x times 1.
Times 1? Yeah, because dinner is 1. I'm just going to leave that out. If you can be pedantic and you can multiply by 1 and you know that that's dinner. And maybe you should always do that. Maybe that's a way to always remember dinner. If that's your strategy, that's perfect. All right. So Rochelle did our first part. Do you guys agree? Arrow Ben, is that 1d2?
Mm-hmm.
All right. So Arrow Ben, I want one of you two to do the second part.
Plus natural log of x times negative e to the x.
Times, say it again. Whoa, I missed you. Sorry.
Negative e to the x.
Negative e to the x. You agree?
Yeah.
Agree, Rochelle? All right. Cool. And we can simplify this a little bit just by writing this as a single fraction, but we're essentially done. I mean, that's also being a little bit too much, but I'm just going to do it for the sake of this is what you need to do on a test. So this now turns into negative e to the x over x minus, I'm going to put that there, minus e to the x natural log of x. Okay, I ran out of room. Can I do that better? Minus e to the x natural log of x. You could have done it minus natural log of x, e to the x. It doesn't matter the order. And I keep forgetting, but I should be boxing my answers. And our final example, and we're done with the notes. This guy, I'm going to consider this a tricky, hard question, even though it looks so nice. the derivative with respect to x. And this is where with respect to x actually means something for the first time. The derivative with respect to x of xy. Yeah, how am I going to do this? What is this going to turn into? Any ideas?
Use the product rule again.
Okay, and what is it going to be?
This is going to be. Well, I don't know what the derivative of y is.
That's a good point, yeah. Derivative of y. This is going back to lesson 2-1 or 2-2. I think it was probably 2-. Yeah, it was either 2-1 or 2-2, but the derivative of y. So when I did these notes in the past, I said d dx of v is the same thing as dv dx, which is the same thing as v prime. So you can choose either this form or this form when you're doing the derivative of y. Probably this form is easier, and both of them are acceptable. So I'm just going to choose this form for our y. So now that you know what the derivative of y with respect to x looks like, solve this problem.
So d over dx of y is just v prime.
So I did it with v here. You're going to replace that with a y.
Oh.
Yeah. So it would be y prime.
It would be x times 1.
X times 1?
No, x
Times y prime
X y prime. That's so far so good.
plus y times
Y times 1. Yep. There it is. And I guess I can write times 1 just so we can see that the derivative of x was there. Yeah, there's our answer. And I guess if you want to boil it down, you could just box your final answer, not including that one. Chunk it off like that. There's your answer. A little bit tricky, but I do expect you to be able to try to solve those. All right, are there any questions? All right, go ahead and do your summaries.